there was light. The world is so bizarre and so unusual that any attempts of the scientists to discover its true nature seems to stumble upon obstacles that cannot be surpassed, and the scientific discoveries most often generate more questions than answers. The science tries to turn the light on a world that does not want to reveal all its secrets. Did you have the curiosity to listen to what top physicists and astrophysicists say these days? They use notions like parallel worlds, multiverse, wormholes, extra dimensions, and they seem to be certain that these notions are sure things and not assumptions that were not fully demonstrated. The science of today is facing challenges that not so long ago seemed to be fantasies, and now the scientists seem to be rather science fiction writers that let their imaginations go further than it should. The world behind the smoke curtains will be analyzed in this documentary that I split in 10 episodes, in which I will try to present to you the main ideas of the scientists of today. We shall see their opinions and the proofs behind the ideas, and at the end of every episode I shall draw my own conclusions. And I can promise you that if you will choose to watch all the episodes, maybe you will have a different perspective upon reality. I am not a physicist or a specialist, and I don't pretend to be one, but I will try to present the notions to you as simply and clear as possible. My purpose is to raise your interest so high that will determine you to seek your own answers for the fundamental questions of life. But what is reality? Let's make an imaginative exercise. Imagine that you are in a meadow on a sunny spring day. The sun is shining mildly, a breeze of wind goes through your hair, and the birds are chirping nearby. The entire meadow is green again. Look at the nature's beauty and feel that life is beautiful and worth living. Everything seems so simple and natural, and the surrounding nature seems to be especially created for your well-being. But what is the reality behind this idyllic and peaceful scene? Science tells us that we live on a spherical piece of Earth that moves through space with a dizzying speed of 100,000 kilometers per hour around the Sun. At the same time, the Earth rotates around its axis at a speed of about 1600 kilometers per hour. Here's the picture we imagine when we want to represent Earth's motion around the Sun, a sun that is imperial and immutable in the center of our solar system, while the planets rotate around it. Most graphics and videos illustrate it like this. But this image is far from being the truth. In reality, the Sun is moving in turn, orbiting around the center of the Milky Way galaxy with an even more dizzying speed of 850,000 kilometers per hour. And this move around the galactic center is being made by Earth and by the other planets of our solar system, prisoners of the Sun's gravity. Here's a much more accurate picture of the motion of the planets and the Sun. We are travelers among the stars. Things seem to complicate more and more. There are already 3 types of motion at incredibly high speeds that affect the Earth, and yet we can enjoy peacefully a sunny day in the middle of the meadow. But is the Milky Way galaxy standing still? Of course not. In turn, our galaxy travels nearly 2.3 million kilometers per hour, or about 630 kilometers per second. But why did I present all these aspects to you? Definitely not to create confusion in your mind. I just wanted to highlight the incredibly great forces that are acting on our Earth, and yet life is possible and prosperous in the turbulent environment at the macroscopic level. But let's go back to the meadow. The wind seems to have stopped, and everything is as calm and reassuring as this meadow defies any movement at whatever speed in which the Earth is involved. But if at the macroscopic level the situation appeared to be complicated, at a microscopic level things seem to be dramatic for the scientists, who shrug off the shoulders, unable to fully understand how the world of subatomic particles works. It is a strange world in which particles emerge and disappear from the real world without any apparent cause. An unpredictable world that can be described mathematically only by complex probabilistic calculations. A world in which you almost have no certainties, but only probable situations. In this world, the subatomic particles have such mysterious properties that scientists have to reach phantasmagoric conclusions to explain them. Here are some of these properties. Entanglement, spooky action at a distance, as Einstein said, is the ability of quantum particles that are in interaction at one point to influence their properties one another, although they have been separated by very large distances. In other words, if we have 2 particles that have been generated in the same place and they have interacted with one another and then separated by great distances, if an action on one of the particles is exerted, this action will be felt instantaneously by the second particle, irrespective of the distance separating them. What is scary about this quantum particle property is that it seems to invalidate Albert Einstein's theory of relativity, which stipulated that the maximum speed at which an object can move in the universe is the speed of light, that is about 300,000 meters per second. And this theory at macroscopic level has been tested and confirmed under laboratory conditions by numerous experiments. The microscopic world seems to be governed by other laws than the macroscopic world. The principle of uncertainty. In the quantum world, a particle cannot be precisely located, but only on the basis of calculations that give us the probability of finding the particle in a particular place. Therefore, the position of a particle cannot be accurately determined, but we can only predict its most probable position. The principle of superposition says that an elementary particle, electron or photon, may be in a state that scientists have baptized a superposition, overlap of two or more states. Thus, we no longer refer to the position of a particle having in mind the idea of the uniqueness of its position, here or there. In the quantum world, we are dealing with here and there. We saw both the macroscopic level and the microscopic level. The combination of these two different levels is creating our reality. And we go back to the meadow again. Is it not a miracle, the existence of this peaceful meadow, now that we have seen the elements that stand behind this reality? Our mind cannot really conceive how it is possible that the multitude of variables that exist in the two planes are combining so well, giving birth to our reality. For scientists, the challenge is to discover laws that govern both the macroscopic plane and the microscopic plane, and which blends these two planes together. And here comes the idea of a theory of everything, which is the pretext of this first episode. When Einstein died in 1955, he had been working already for years on this theory of everything, which proved to be too difficult to formulate, even for the great genius. Since then, the physicists who have followed Albert Einstein have constantly tried to formulate this theory of everything. In physics, the Standard Model represents the current consensus of physicists on the constituent elements of matter and on the fundamental forces describing the interaction between them. In the Standard Model are presented 61 particles considered fundamental and 3 of the 4 known forces: electromagnetism, strong force, and weak force. But the Standard Model cannot be a theory of all things because it cannot integrate into the whole the 4th fundamental force, gravity, and is incomplete at this moment from a mathematical point of view. That is why I will not speak about it anymore. In the last decades, a strong candidate for a theory of all things has emerged, and this candidate is called string theory. Meet the physicist Michio Kaku, one of the most famous physicists of our time, a professor at City University in New York, and also one of the founders of string theory. Let's see what he has to say about this subject.
We can also unlock the secrets of the Big Bang. You see, Einstein's equations break down at the instant of the Big Bang and the center of a black hole. The two most interesting places in the universe are beyond our reach using Einstein's equations. We need a higher theory, and that's where string theory comes in. String theory takes you before the Big Bang, before Genesis itself. And what does string theory say? It says that there is a multiverse of universes. Where did the Big Bang come from? Well, Einstein's equations give us this compelling picture that we are like insects on a soap bubble, a gigantic soap bubble which is expanding, and we are trapped like flies on flypaper. We can't escape the soap bubble, and that's called the Big Bang theory. String theory says there should be other bubbles out there. In a multiverse of bubbles, when two universes collide, it can form another universe. When a universe splits in half, it can create two universes, and that, we think, is the Big Bang. The Big Bang is caused either by the collision of universes or by the fissioning of universes.
Ever since physics was born, it was believed that matter was made of particles. Now many physicists have changed their mind on this matter. Now they think the matter is made of small strings. String theory says particles are actually invisible small strings from which matter emanates, like music from strings. If you rope in a certain way, you get a certain frequency. But if you spin it in another way, you can get more frequencies, so you have different notes. But this string theory has a peculiarity that gives scientists a headache. In order to function, it requires a universe of 11 dimensions. As we know, the accepted version of science is that our universe consists of 4 dimensions: height, length, width, and time. The followers of the string theory say that the rest of the dimensions up to 11 cannot be perceived. 6 are wrapped and 1 is containing the other 10. Until they cannot demonstrate experimentally the existence of these additional dimensions, the founders of string theory seem to have hit an obstacle that can be fatal for the theory. And yet the followers of this theory say that the mathematics generated by this theory is too elegant and too convergent to be the fruit of a happening. That is why many physicists continue to look for ways to demonstrate the validity of this theory. But there are physicists who think string theory is wrong, and they look for other solutions. They come with their own candidate proposal for a theory of all things, and here is one such candidate. Emergent theory E8 is a theory that a group of Los Angeles researchers have developed, according to whom reality has the structure of a crystal, being formed at the fundamental level from pyramidal geometric shapes, tetrahedra, and from the way these tetrahedra combine results our reality.
Our best physics theories, Einstein's theory of relativity and quantum mechanics, both use the speed of light as a starting point. In other words, they use an inexact measurement of the speed of light without explaining why it is, what it is, or why the universe even has a speed limit in the first place. We need a new theory. And such a theory is what the physicists and mathematicians of quantum gravity research in Los Angeles are working on. They call it emergence theory, and it will, really for the first time ever, provide an explanation for the speed of light and the other constants, such as Planck's constant and the fine structure constant. Basically, what is needed is a theory of everything, a theory that explains the very fundamental aspects of reality. String theory, which once held a lot of promise for possibly being a successful theory of everything, has not made any successful predictions. And regardless of predictions, the theory itself isn't actually a theory of everything. It's just not, because it can't explain the speed of light or the other constants. Quantum mechanics and general relativity, on the other hand, do make good predictions, but they don't explain the fundamental constants either.
Professor Einstein, why does the speed of light have the exact value that it does?
Well, to put it plainly, security!
It is a very difficult theory for those who come from outside the academic world, and it started from the mathematical notion of Lie groups, E8 being an example of a Lie group, namely an 8-dimensional crystal. A crystal is a homogeneous body whose constituent particles, atoms, molecules, ions, are arranged in a 3-dimensional internal structure in different systems of symmetry. We are still far from having a theory of all things, and scientists are likely to have this problem for a long time. But is it possible to formulate such a theory? There are strong clues that this universe might be an emanation of an existential dimension to which we have no access, and for this reason we will never be able to truly know all the properties and forces that have generated our universe. But how much do scientists really know? We should ask this question when we make value judgments about science in general. Scientists say our universe is composed of visible matter, galaxies, stars, planets, asteroids, dust, representing about 5% of the universe, of dark matter, that accounts for 27% of the universe, and dark energy, representing 68% of the universe. Virtually what we could see directly using our modern telescopes represents only about 5% of the entire universe. If we take into account that the scientists have not succeeded in uncovering all the mysteries of our visible universe, and that there is much speculation about many things in our visible universe, we can conclude that the scientists have failed to fully understand the 5% that make up the visible matter in the universe. As for the remaining 95% of the universe, composed of dark matter and dark energy, scientists know almost nothing. Both dark energy and dark matter are hypothetical notions, assumptions that scientists have guessed and deduced by watching the galaxies move in the universe, but there is no palpable scientifically proven evidence that they exist. They cannot be reproduced under laboratory conditions because their basic properties are not known, and practically, as the names say, they are totally dark notions for scientists. At the microscopic level, scientists have even more uncertainties. We cannot tell why subatomic virtual particles appear and disappear from our universe without being able to predict either the place or the moment they appear. Also, scientists do not know why particles retain an instant link with each other, although they are separated by large distances, as we saw earlier. They can not precisely locate the position of a subatomic particle, but only if they resort to probabilistic calculations. There are so many uncertainties at the subatomic level that we can say they are more unknown than known. And then you cannot ask yourself how much knowledge scientists really have about our universe. The answer is obvious, much less than we all thought. And yet scientists say that they are very close to achieve a theory of all things. How can they be so perky with so little knowledge? We'll see the answer a little bit later. Imagine that you are back in school and you are in front of the physics professor who will evaluate you. If you tell him that you know about 5% of the lesson you should have presented, which would be the outcome? Probably a small grade if the teacher is merciful by nature. Under these circumstances, scientists that are asking us to accept everything that they pose as immutable truths, what grade would deserve? But let's not forget that the problems that scientists have to solve are extremely difficult because they just do not have all the data needed to solve this fantastic puzzle of the surrounding reality. Let's take a quick look at the most important theories in physics. The famous Big Bang theory tells us that the universe began with the expansion of a very hot and dense point that exploded, generating all the things in the universe. This theory does not tell us anything about the origin of that extremely hot and dense point, but the fundamental question is how it was possible to create a whole universe and generate the four fundamental forces that have led to the formation of heavenly bodies after the Big Bang. Also, scientists cannot explain why there is matter in the universe, because according to their calculation, the Big Bang should have created in equal proportions particles of matter and antimatter that would normally have to destroy each other, and so why there is any matter in the universe is a mystery for the scientists who support this theory and who think that the creation of the universe is pure luck because there were more particles of matter than antimatter. In the string theory, we are told that the universe would have been created by the collision or the fragmentation of universes, and they are proposing the concept of multiverse. And whatever details this theory would give us, it can never give us the answer to a fundamental question, which was the origin of those universes. Was there a primordial universe, and how did it start? Also, as we have seen in the previous film, many scientists are challenging this theory because it cannot explain the speed of light and other fundamental constants in physics. Most scientists eliminate God from the equation. God has nothing to do with science that is freed by the prejudice of the Middle Ages. God is regarded by most scientists as the prejudice of non-cultured people who, being unable to seek answers through scientific methods, put their hope in imaginary divinities. The superiority of science, they say, is obvious because its discoveries can be mathematically demonstrated and reproduced in laboratory conditions, and the effects of science can be seen in our everyday lives. The technology with which humanity is endowed at this time is the result of the work of scientists over the centuries. And yet, perhaps science is not so different from religion. Science has its own God, and it is mathematics, a cold, inflexible, and inanimate God. The dream of any scientist who wants to develop a theory of all things is to obtain a mathematical formula, not very long, containing all the elements necessary for a valid theory of all things. Einstein's famous equation E = mc squared has become an icon, worshipped by all scientists. The mathematics has become the unmoved God of all physicists, who honestly believe that through mathematics they can explain all things existing in the universe. And so, an imperfect working instrument invented by the limited mind of man has the power of a God in the minds of scientists. And so I ask, is there so much difference between the God found in religion and the God of science? There is a huge difference between the reality we perceive in everyday life and the reality behind the smoke curtains, a reality that we may never be able to fully understand. Scientists are trying to shed light on this miraculous world, but at this point they are often defeated, unable to give a real explanation to the multitude of inexplicable phenomena in the surrounding reality. Science is absolutely necessary for the development and future of mankind, but a God-free science can at any moment get monstrous dimensions. And at the current level of technology, mankind can be completely destroyed in just minutes by science. This is the reality. And then the question arises, is a God-free science really useful? And yet recently, a third way is emerging through which science and religion seem to be on the verge of a forced reconciliation. But that's what we're going to talk about in the next episode.